Hi, my name is Sean Ross, and I'm here to give you a quick rundown on my project, Integrating Green Infrastructure into Coastal Engineering, a sustainable approach to mitigating sea level rise and storm intensification. As many of us know, global climate change is set to raise mean sea level by up to 1 foot over just the next 25 years. This is caused largely in part to the melting of sea ice at the poles. For the scope of this project, we're not going to be looking at mitigating that specifically, but rather how we can deal with the effects of it. Our current coastal infrastructure was designed over 100 years ago and is not set to take the load of that 1 foot, which will cause inundation, severe flooding events, and have large impact at our port facilities worldwide. And so this project will be looking at how we can eco-engineer solutions to create a more sustainable and more useful littoral zone for both humanity and for the environment. Jumping into the first slide here, this is a map of the globe in every major port throughout the world that is going to see some sort of change with that 1 foot of mean sea level rise. As you can see, the Mediterranean, Africa, and the Middle East are going to be exceptionally hard hit by this. Luckily, in the United States, we've been doing our best to try to mitigate this quickly, and we've been engineering around it for years. However, there are still ways that we can go about this in order to increase sustainability measures. This is a just kind of flowchart diagram looking at what we're going to be doing here with hard protection and soft protection. These encompass not changing our day-to-day basis around that mean sea level rise, but rather creating defenses that protect us from it. So that soft protection is going to be beach nourishment. That's going to be putting sand back. That's going to also include dredging operations of channels. And then our hard protection those are dikes, levees, dams, sediment barriers, groins, jetties, just anything that's going to physically stop the water from coming in. Seawalls, quay walls. So jumping into how we can manage sediments more effectively in the future. Sediment management is one of the most critical aspects of our impact in the littoral zone. We need shipping channels to facilitate global trade. Up to 80% of all shipping by volume happens over the water. So these are super critical areas for humans right now. The main way that we do that right now is by maintenance dredging, which is absolutely horrible on an environment, as that is a maintenance dredge, a cutter suction hopper dredge up there in the top right. Essentially, that has a large drag head on the bottom that scoops along the bottom, sucks up that slurry mixture. And in this picture, it's shooting it off into the water where it will basically just mix in with the environment and the currents will wash away. What also can happen is with that picture there in the middle, it gets put into a dump scow, which takes it to a depository zone a couple miles away from the critical infrastructure. But these absolutely wreak havoc on benthic ecosystems. It completely takes away the bottom floor and increases turbidity in these environments, which has negative impacts on dissolved oxygen. So what we can do to try to mitigate the need for that is something called sediment training, which on that bottom right here, those are subaqueous dikes that are essentially creating currents that reduce the chance that sediment will build up in those channel areas. It essentially creates a void space for them to flow past and not build up, which is our goal in this operation. There on the left, that is the sand motor. That's the largest beach nourishment project ever done. That's in Netherlands, moved 21.5 million cubic meters of soil in order to replenish that beach. These are some living seashore defenses. That's a salt marsh right there, which is great for carbon sequestration. And then over on the right, we have a oyster bed, which helps with wave attenuation in those low impact environments. That really reduces the backing of that salt grass that you see behind it and allows for reduced erosion. Finally, this was something cool that I had just seen. There are some spots where that living seashore defense isn't going to be enough. We need a seawall, we need a quay wall, some hard infrastructure. But what we can do is engineer around it. And those are actually little mini tide pools built into the wall there on the right. That's in Sydney, Australia. And that's a 110% increase in species diversity on the wall. So that's home to crabs, algae, anything like that. And then the left, that is a seawall in Seattle, where that's actually habitat for juvenile salmon. So they can grow up and have a little bit of protection. Thank you. I hope you were stimulated by this and you want to do your own research into it. My proposal is a great way to get started. Thank you.